You're listening to WMPG 90.9 Gorham, Portland. Okay. Live from the Orion Cygnus arm of the Milky Way galaxy, this is Scientifically Speaking, a weekly half-hour program devoted to elegant curiosities, and I am one of your hosts, Sarah Chang, and joining me, as always, is Bernie Rhyme, DJ Starwatcher. How are you, Bernie?
Yes, hi, Sarah. Very good.
Bernie is our professor of the astronomy lab at USM and our local protector of the night skies. You're listening to WMPG 90.9 Gorham, Portland. Number to call is 780-4909 if you've got any specific questions on WMPG. And then you can always go to wmpg.org to find out more and all of the last 5 weeks of archives of all of your favorite shows. Reach out to us at WMPG Scientifically Speaking at gmail.com or on Twitter at WMPG Sci Speak. Bernie, what's up in the night sky for this coming Halloween weekend?
Yes, thanks for asking, Sarah. Yes, we have an interesting week coming up. We actually have the second full moon of October. It'll be October 31st. That'll be tomorrow for Halloween. And anytime you get two full moons in the same month, that's called a blue moon. It doesn't mean it'll be a brilliant blue color or anything, but it'll be interesting to have a full moon for Halloween period, and then having a second full moon would be kind of interesting. And then you should be aware that by the end of November, we'll be in an eclipse season, and we're going to have a partial penumbral lunar eclipse, where we see some of our shadow actually crossing over the moon's face. It won't be easy to detect, and we'll have lots of time in the future to tell you more about that. But get ready for the next full moon after the one tomorrow will be eclipsed by part of our shadow. And other than that, you can still keep watching Jupiter and Saturn. They're getting closer and closer together. They'll be about 5 degrees apart, and by the end of next month, it'll only be about 2 degrees apart. And then on the winter solstice, they'll be 1/10 of a degree apart, the closest they have been in 400 years. So keep watching that. It's about 1/10 of a degree per day, so it might take you a couple days to really notice it, but definitely within a week, it'll be a good fraction of a degree. You can keep watching it that way. And then, of course, Mars, it was at its best a couple weeks ago, but it's still very nice. It's up before sunset. As soon as it gets dark, you can see it in the east. Nice, brilliant campfire red object that's, again, getting further away from us, but it's still very bright, much brighter than usual. And then if you like getting up early or staying up late, you can see Venus around 3:30 in the morning. So those are the planets and the moon, and that's basically what's coming up.
It's awesome. Thanks, Bernie.
You're welcome.
And if Bernie talked way too fast, you can also check out the monthly What's Up column in the Portland Press Herald. Bernie, would you do us the honor of introducing our guest du jour?
Yes, okay, thanks, Sarah. We're very lucky to have Chase Stevens with us today. He was on our show several years ago, so many of you may not have been listening then or may not remember him, but he did an excellent job back then, and he's done quite a few more compliments now since he's been on with our show last time. So he is the principal data scientist for a company called Metrics in Boston. He also has a Master of Arts degree in Cognitive Science from the University of Edinburgh and a Master of Science degree in Artificial Intelligence. So basically, I think today we were going to talk about artificial intelligence, its relation to 5G, some of the latest aspects and applications of it, and just to get people ready for a lot of the future things coming up in those fields, which are very important now for a lot of reasons. So Chase, would you like to start out then?
Sure, thank you for having me.
Oh, yeah.
So yeah, I think Bernie, you want to talk about some of the interesting developments in AI as of late, and I think we're pretty fortunate that there have been quite a few interesting developments, especially around the field in which I specialize, which is natural language processing. So I can lead you through a few of those recent results, but there have been some unanticipated accelerations, I think, in the development of really impressive artificial intelligence technology. So I'll go ahead and catalog some of those if you like.
Yeah, tell us more about the natural language processing.
Sure. So, I mean, I'll start at a very basic level, like what is natural language processing? And it might seem like a given now, since we've actually gotten pretty good at it. But it's important to remember that computers by default are sort of very fancy adding machines, and they don't understand, for instance, the English language, right? You have to sort of tell them how to understand English. So, back in the olden days, in the 50s and 60s, and that sort of period, there was some initial research done where we were trying to sort of hand teach the computer how to understand language, how to make sense of it, and particularly this was motivated by the desire to be able to translate Russian into English, as you might imagine.
Right.
So that's really one of the primary applications, especially for military applications, of this sort of early AI. And it was realized pretty quickly on that unfortunately the sort of hand-woven approach wasn't going to work, and that to understand the sort of very complex, nuanced organism that is human language, we would need to be able to have the computer sort of learn for itself, just like humans do when they're born and exposed to whichever languages are around. So that's sort of the primary conceit behind the field of natural language processing is we want to, for some application, have the computer be able to figure out how to process natural language, normally English. That's where most of the research is done on its own. So some examples would include, say that I want to take a long newspaper article and sort of summarize it into 2 or 3 bullet points, would be an example of natural language processing application.
Can I ask something? As you're talking, I just came across this potential idea of a treasure trove of information for someone like Google, or an organization like Google. So I don't know if you're familiar with the reCAPTCHAs.
Mhm.
Okay, so the reCAPTCHAs are those, it's like some image, scrambled letters or words that, the computer or some login will be like, you have to enter this before, to confirm that you're human or something like that. And I can't remember the professor who kind of led that project for the reCAPTCHAs, but they had kind of 2 images side by side where one, they kind of knew what the word was, and the other was some word that had, when scanned in from like Google Books, so they were trying to digitize all these books. It was maybe the page kind of was folded over, or it was just a little unclear, and so they used kind of that mode to get humans to try to interpret what that word was. And, if they get a certain percentage of whatever the word is, they would say, okay, this is probably this word. And so I don't know if it's related at all, but it kind of reminds me of, I don't know, for like YouTube, they have those auto-generated subtitles.
Mhm.
And in Google's suite of, their version of PowerPoint, and if you present on Google's version of, is it Slides? I think it's Slides. You can kind of do this auto-generated subtitles of the speaker in real time. Do you happen to know, and this might not even have an answer, but is Google using that as a way to get a computer to understand our speech patterns?
Yeah, so I believe that they do use those captions. So I think originally YouTube allowed you to, or I suppose it still does, allowed you to upload captions manually. And I believe Google explicitly was using those to sort of help train its natural language processing algorithms in order to be able to produce those automatic captions that you were talking about. And that's one field in which natural language processing has really starkly advanced, is the speech recognition side of things, where if you think back, I don't know, 10 years ago when you were calling, I know Google had something like an automated 411 where you could call and the speech recognition was not that great. Or if you think about talking to your phone, if you even bothered talking to your phone 10 years ago, it was not very good at understanding what you were saying, especially if you had an accent of any sort or anything like that. And that's one area where we have really basically solved the problem of speech recognition for the common cases, even in noisy scenarios or multi-speaker scenarios where you have to decipher who's participant A and who's participant B and things like this. And that's really come to fruition mostly on the back of new techniques like neural networks and particularly deep learning.
Yeah. I mean, it's interesting that you mentioned that because so I have a Google Home and I talk to it. And, I know that people are like, I don't want to listen to me. But what's interesting is, so my partner and I both share the Google Home. And, you were talking about it, how it can distinguish multi-speakers. I guess it can tell, it records our speech to kind of be able to recognize it. But sometimes if I talk really low, then I can trick it,
Yeah, and if you look at the problem from a in a lot of things in AI, really the challenges we've been having are prior to the last, I don't know, five or so years, have been in sort of these very basic perceptual tasks that humans are really bad at describing. So things like chess, back in the 90s, sort of these more intellectual pursuits, we got really good at really quickly. But some of the harder things for AI have been things like vision and understanding sound waves, things like this. And if you look at human speech, the human brain, actually, when you're growing up, does a really great job of sort of learning to classify different sounds as different sort of conceptual phonemes in your head. So if you look at the actual like waveforms of some of the sounds, the way that I produce an sound, an M sound, versus how you produce an M sound, versus how Bernie would produce an M sound, all look on the spectrogram very, very different. But the human brain adapts to the specific sounds in the language that you grow up learning. So these are the sort of problems where AI has done really poorly, because it turns out that humans both are, because it's innate for us, very hard at explicitly describing the precise process of how to understand those sounds. And it's been a matter of basically faster computers, newer techniques, like I've said, like deep learning, which have been enabled by those faster computers, and also sort of the big data revolution, where we have so much more training data available for those algorithms, like the YouTube captions, like you were just mentioning.
Sure. I wonder, so you had mentioned it's basically, at almost like pretty good at being, I don't know how you described it, but just we're at the epitome, or at the apex of being able to recognize speech pretty well. So I actually do have a proposed problem that I don't believe has been solved yet. And I don't know if people are pursuing the solving of this problem. But so for people like me, so I'm bilingual, and I often mix languages.
Yes.
That it cannot do that. Like, it cannot recognize that I'm speaking like another language within, or like two different languages at the same time if I'm mixing language within a sentence.
No, and that's something very important to always note when you're sort of thinking about artificial intelligence or machine learning or any of these sorts of things, is that really the algorithms are being trained to work on the input set that they're given. So if they're not trained on sort of multilingual utterances like that, they're not going to perform very well. And in particular, in the field of speech processing, the difficulty is that you're both trying to understand these sounds and also trying to sort of predict ahead of time, well, what is the next word going to be, or what are the probable next words going to be? And then that can help you sort of differentiate between, oh, it might be this word or this word, they both sound alike, but which makes more sense contextually in this sentence. All those sort of models that are trying to predict what's the next word, what's the next word, what's the next word, are typically speaking trained on just single languages. So if you're mixing and matching languages, they don't do particularly well. But I think that that's more of a case of not having the right data sets to be able to train on, as opposed to the techniques not necessarily being there.
Interesting. I know you mentioned kind of training data. Do you think you could kind of describe that for our listeners? I'm not sure if that's something that's so familiar.
Absolutely. So again, the idea behind sort of modern artificial intelligence, and certainly what I do, is you're not sitting down and telling the computer, well, if this, then do that. If this other thing, do this other thing, et cetera, et cetera, et cetera. It's really more of a matter of trying to get the computer to understand patterns in the data you present it. And typically speaking, the way that you train these sort of systems is you sort of know the right answer ahead of time, right? So you have some sort of waveform or some sort of audio recording that you're feeding into the computer in the case of speech processing, and you know ahead of time you've either taken it from some source that already has it transcribed, or you've had your grad students in your research lab do the transcription, or you've hired a bunch of people through Amazon Mechanical Turk online to do the transcription for you. But someone has to go through and actually produce a some like corresponding quote unquote labeled data set, which is to say it has the input that you are giving to the machine and the output that you expect it to have. And so you present the machine with this over and over and over again, and you will have some sort of procedure to, when the machine makes a mistake, so it produces the wrong word or is totally incorrect, you have a little procedure to sort of slightly adjust the parameters of the machine learning model, and you such that it's a little bit better every time. And you keep doing that over and over and over again. And in that way, you're sort of telling the computer how to learn on its own, how to understand that correspondence between the input, in this case, the audio file or waveform, and the output, which is sort of your English language text that you'd like to produce. So that's really where the training set comes in, is to have that labeled data set. And one of the things we've learned about artificial intelligence, especially in the last, let's say, 15 years, is that we can develop new algorithms that do better and better and better, more sophisticated algorithms to make progress in that way. But another way you can make progress is, and it's actually surprisingly effective, just present more and more data to your existing, maybe not so sophisticated algorithm. And the more data you present, even if the learning process is not very complex, you can do a lot better. So particularly, there's been a recent suite of papers out of OpenAI, which is a nonprofit organization for studying artificial intelligence, and particularly quote unquote general artificial intelligence, sort of human level artificial intelligence, and also importantly, the field of artificial intelligence safety. So if we produce a very powerful artificial agent, making sure that it doesn't take over the world or anything like that. But as of late, they've been making headlines through a model called GPT, which is a language model. So the sort of thing I was describing before, where you have some input text and you want to guess, well, what's the next word, and what's the word after that, and what's the word after that. And they have shown that with the technique that they're using, which is a fairly modern technique, the more data they've pumped into it and the larger they make the model, it's been getting just better and better and better and better, up to the point now where it's very, very difficult for humans to distinguish between text that it produces, so sort of stuff it's writing, against human writing. I think it's something like humans have a 51% accuracy rate or something along those lines of distinguishing between this artificial agent and what it's written and what a human would have written. So just as an example of how the more data you feed into them, the better they get, really.
Yeah. That makes me think of I think it was maybe a year ago, Gmail rolled out the kind of predictive next sentence that you might, or it would finish your sentence. Is that, is that Google reading our emails and reading how we type? And
yeah, so it's certainly Google reading your emails. It's also Google leveraging, Google has a distinct competitive advantage in this field because they, in some sense, were a natural language processing company from the start. So the way that Google search works, they have an algorithm called PageRank, which is one way of sort of weighting pages, but they also use, or I'm sure they use much more sophisticated techniques now, but back in the day when they were founded, we're using an algorithm called TF-IDF, which is basically one means of when you put in your natural language search query, trying to figure out what websites are most relevant to what you're searching for. And part of doing that is going through as much of the entire internet as you can and trying to catalog and index every page you can find so that you can serve that up. So Google are in a great position because they have this huge trove of natural language data that they can use from the internet, in addition to, yes, things like your email or things like the other data they collect through Android, through sort of the OK Google Assistant, things like this. So I don't know. Don't ask me what their privacy policy is there. I think that they, I do think that they try and anonymize that data, and I know that some of their models are going to be tuned specifically to you. So they might have a sort of general English language model, and then a Sarah English language model, and a Bernie English language model, and a Chase English language model that are sort of adapted a little bit to the sort of text that we write often. So that's where that sort of all that data for training that exactly sort of, I guess, predictive text feature in Gmail has come from. And GPT, which I was just mentioning, is sort of that same concept, but writ large. So not just finishing your sentence, but finishing, an entire book.
Right.
So Chase, you said you couldn't tell the difference between what the computer writes and a human? So
yes.
Computers write original things on these programs?
Oh, yes. And I should say that probably quite a lot of your listeners will have read in the past articles written by artificial intelligence and not known it. So this is particularly prevalent in, for instance, the financial field. So quite a lot of financial articles saying, oh, this happened, this equity went up this much, or oh, bonds dropped because of this other thing. A lot of those are written by artificial intelligence agents. But that's sort of a very, I guess, constrained use case where it's easier to produce those. So those have been in use for quite a while. I know that on Amazon as well, you can buy a lot of books that you might not realize are written by artificial intelligences.
Yeah, I never knew that.
Yeah, particularly nonfiction.
Yeah.
But GPT is really the one where it is able to be applied to a dizzying array of different types of text, different genres, different fiction, nonfiction, news articles, poetry, even writing computer programs. So that's it's sort of a very broadly applicable model, and also one which is much more coherent and as a result much more indistinguishable from what a human might produce than some of the previous work.
Interesting. Poetry and all kinds of things.
Yes, it's actually. I would encourage anyone listening to look up some of the GPT example productions. So I think one of their very first models was one of their very first examples from an earlier model was they gave it a prompt something along the lines of, oh, in Sao Paulo, unicorns have been discovered. in a sort of news article way, and now
Yeah.
complete the rest of this article. And it went on to say, oh yes, they were discovered by Dr. So and so, so it knew that typically when you have a research announcement, there's some professor that's associated with that. They described them sort of going into the valley and seeing the unicorns, and it was able to keep sort of track of all of the pertinent details that both it had been presented with as the prompt and sort of itself produced all the way through the article. And there were a few things that were a little odd. It would talk about, the unicorns had 3 horns because they didn't really understand what a unicorn was necessarily. So that was GPT 1 or 2, I believe. GPT 3, which is the latest one, is the one which is virtually indistinguishable from human writing. And if you look up examples from that model, they are a little on the scary side in how realistic they are.
Yeah. I mean, you can actually look on YouTube of songs where they have, they'll play the original song and then have the computer finish the song with, the melody and everything. And it is odd. I don't think with the songs they're quite, I don't know. The ones that I heard were not, they were a little muffled and a little odd, but it was very, considering they're just making it up, it's not bad.
Eerie, right?
Yeah.
And really what that's relying on, what that's hinging on is human language, just like music, has sort of these underlying patterns and rules that it's following. Used to be the case in natural language processing back in the 70s or so, that you'd have a lot of linguists on your team to help figure this out. And at some point we realized, no, just ditch the linguists and add more computing power to it, and it works much better, which is unfortunate for me since I spent a lot of time studying linguistics, but oh well. And so, it's the same sort of concept where it's just trying to infer these patterns and predict, well, what's most probable to come next, given what I've seen before. Again, contingent on having the training data to be able to learn from.
Yeah. You've been listening to Scientifically Speaking here on WMPG with myself, Bernie, and Chase Stevens. This is part 1 of a 3-part series, so check out next week's episode to continue listening to this conversation. Stay tuned for Sports Jam with Cullen and Connor. And from your favorite nerds, mask up, and we wish you healthy bodies and clean air.